Good evening, everyone. Happy New Year. Yeah. So wishing you all the best for 2011. Looking forward to another wonderful year of observing interesting events, that sort of thing. Welcome all to the January 7th, 2011 meeting of the Ottawa Centre of the Royal Astronomical Society of Canada. A little bit light attendance tonight, not a big surprise given the weather. Usually this time of year we see a little thinner crowds. That's okay, welcome all. Do we have any people here, non-members, visitors for the first time, that sort of thing? Oh, the entire place. Good. Always glad to see new people dropping in. As we mention every time, you don't need to be a member to attend the meetings. Anyone is welcome to attend. There are some benefits to membership in the society, but I would say for the first while, just hang around, soak in the ambiance, enjoy the show, and you know, if a couple of months or a year from now you decide you really like this and you'd like to become a member, well, there's people you can talk to. There's a website you can go take a look at and find out about that. But for the time being, no stress. Sit back and enjoy the show. So going on, let me see now if I can get this to work. Yes, it does. Good. Our program for tonight. So a little bit of a thin program tonight. I don't think it'll be too short, but nevertheless, start off with Ottawa Skies. I've been doing it the last couple of meetings, and I'm having a good time, so I'm going to carry on with it for a little while. Talking about what's in the sky over the upcoming month, what you can observe, and a few points about you know, the sky at this time of year. Followed by Sylvie Létourneau, who's doing our 10-minute astronomy news this month. Followed by Mike Moghadam, who is doing an update on public outreach. I think he's got some news for you. Pete Heyman telling you about an astronomy club that's started up at Carleton University. Our break, observations as usual. This is the observers meeting after all. And Chris Tarrant is going to speak to us tonight about astronomy applications for the iPod and iPhone platforms. So should be an interesting program tonight. Starting off, we have a couple of our published photographs from one of our members. I'm embarrassed to say I don't recognize the name of the member, but they are stated as being a member of this center. Tony Peterson. Does anybody here know Tony? Is that Tony? Good evening. Congratulations, Tony. Well done, well done. Very impressive show for somebody we've never heard of before. Yeah, I wish we could all do so well.
We expect submissions every month now.
Yeah. So my question is, why have I not seen any observation photos being submitted for the meetings? I want to speak to you in my office later. All right? Okay. Well, anyway, well done. Congratulations. Very good job. So going on from there, we've also got an article published by one of our members this month, Glenn LeDrew. Pardon me? I know him too, yeah. Congratulations, Glenn, well done. So lots of good exposure for membership of the center, I'd say. So we'll start off with Ottawa Skies. And as you've probably noticed over the last little while, I'm trying to stay fairly light with this, more on the introductory level, I guess, but let's take a look at what's going on. First of all, solar. You may remember this photograph in the corner here from last time. We're starting to see more and more sunspots coming around. So it appears that we're coming out of this period of solar quiescence that we'd been going through for the last year or so. And it looks like we're starting to get some interesting activity. I don't suppose everybody's happy about that. If you happen to be taking care of telecom systems or something like that, it's a bit of a problem. You start getting coronal mass ejections and problems in your networks. But as far as we're concerned, they're very interesting to look at. Good on it. we'll see more and more of that. And of course, one of the results of increased sunspot activity and coronal mass ejections is you see more active auroral displays. You get those really pretty displays at night, especially this time of year, if you ever get a clear sky, that is. 2011 is shaping up to be pretty good. There have been already some good observations from Scandinavia and northern Canada, the Yukon Northwest Territories. So we can probably look forward to, once the snowy stuff passes us by and we get into those clear, cold nights, we may see some very good displays this winter. So should be kind of keeping an eye out for that. So here's an example of one. This was taken just a couple of weeks ago well, it's taken by a fellow in Sweden. I'm not sure if it was shot in Sweden or in Lapland, but, Scandinavia, somewhere up there, one of those countries. Anyway, beautiful display, as you can see. And there's more and more of these things turning up, so great. I'm very happy with that. Okay, lunar. So not a heck of a lot that I can say, oh, there's something amazing happening this time. There's lunar guys who probably could jump up and say, but new moon is either a few days ago on the 4th, and the next one is February 3rd coming up. So dark skies. For the rest of the observers, it's usually, oh, new moon, good, the moon's gone. Now I can look at other stuff. So I'm pointing that out mostly from that point of view. As well as that, though, if you're kind of collecting your stamps as far as lunar observing goes, you're a little bit challenged to look at those things that are around the corner. They're not right out in the middle of the moon, but they're kind of on the edge and they're hard to see. You can't quite tell. Well, the moon rocks back and forth, both from side to side and also up and down, depending on its position, libration, as it's referred to. And so if you pick your day, you have more or less exposure of one edge or the other of the moon. You can see things that are kind of around the corner. So in this case, I thought, I've never seen somebody put this up for lunar observing before, but I thought it might be of value to those who want to look. The southern limb of it is most exposed on the 10th. And, well, you can read the rest, right? You don't need me to read it all to you. But the story is that there's certain days that are good for particular observing. So, I don't know, if you're taking a snapshot or something of this, or you want to look it up somewhere, it's really handy to have in mind. If you're looking out the window and you're saying, hey, dear, the sky's looking pretty good, keep the bed warm, I'll be back in a couple of hours, then it might be handy for you to know that, oh, it's the 16th. Gosh, the western limb of the moon is at its most librated, it's best exposed. I should take a quick look in my Ruckel and see what's on the western limb that I haven't seen before. That's a good place for me to look tonight, right? So it's just kind of something for you to keep in mind when you're doing your lunar observing. Okay. Planetary, so just the rundown really quickly. Neptune is setting pretty early right now, but nevertheless it's observable. Binoculars, that sort of thing, if you know where to look, it can be picked out. Of course, presuming we don't have clouds in the sky like we do now. Jupiter is well placed in early evening, and Uranus also is very close to Jupiter. So it's kind of, if you've never seen Uranus, it's real close to Jupiter, so it's kind of easy to find right now. Other times you might have to try and pick it out. You're not sure whether you're seeing it or a star or what you're looking at, but make it a little easier. And then in the morning sky, Mercury is low in the morning sky, but it's pretty good apparition right now. It's not bad. Venus, of course, is out there, and Saturn is well placed before dawn as well. So all of those are pretty good to look at if you happen to not be able to sleep, or you got in trouble and now you've been kicked out of the bed for good. Okay, and of course Mars and Pluto, unfortunately, not good to look at this month.
Bill,
yep.
Your next slide you won't know is there, but that's
You're right.
accurate for today. That's a teaser of an app.
Ah, wow, that's pretty cool looking. I wish I'd done that. So this looks to be something, as Chris says, it's a teaser of an app. So he's going to talk about iPhone applications a little later in the night, and it looks like he's got a little screenshot from one of them. My iPhone doesn't look that big, but...
That explains why you don't see Pluto and Mars. That's accurate positioning for today.
Yeah. Wow, that's pretty cool looking, though. I must say, the image is very nice. Okay, so in the evening, as I've been saying, you're going to find Neptune is pretty low in the southwest. You can see it's right here. I don't know if that text is really big enough for you to read well. Maybe I'll increase it for next time. But Neptune down there, and I believe this was for tonight, so if you could see the sky tonight, which you can't, but if you could see the sky, the moon would be there. Hey, did anybody catch the really thin crescent moon last night? Yeah, I did too. That was cool, wasn't it? That was really nice. You know, like it wasn't an amazing, like a personal record or anything, but it was still nice to see. You only get to see those a couple of times a year at most. And yeah. Yeah. It was, oh, did you catch it? I didn't catch it the night before, but it was good. Yeah, I like that. And we get so few clear breaks that, you know, anything in the sky is nice. Well presented for the drive home, I say. Okay, as well as that, as I said, Jupiter and Uranus are very close together here. They're you know, within the same field of view.
Isn't tonight the closest night?
Yeah.
It's about the full moon width on each side, about 31 arc minutes.
Yeah, thanks, Gary.
They're widening now.
Yeah, that's right. But they're still really, really close, you know, close enough that it's going to be real easy for you to find one from the other. And I'll let you figure out which one you'll find from which. Yeah. Anyway, okay, yeah, smartass. Okay, so interestingly enough, Neptune happens to be in pretty much the same place as it was in when it was discovered, okay, in 1846. And this is the first time it has. That's how long the orbit of Neptune is. It's only gone around the sun once, and it's back in pretty much the same place it was in when it was discovered. So that's kind of cool, right? What is it? Let me see. Interesting. I guess you guys are probably reading ahead of me, right? I'm taking a little too long. But it was discovered by mathematical prediction. Basically, they were looking at Uranus and noticed it wobbled in its orbit. You know, kind of like nowadays they're discovering exoplanets by looking at a star wobbling. One of the methods that they use is they look for the star to wobble a little bit. Well, in those days, of course, they didn't have the fancy equipment we have now, but they were able to observe that Uranus was not regular in its orbit. It was wobbling around, and they sort of went, well, what would cause that? There must be something else out there that's gravitationally pulling it around to cause it to do this. So did some fancy math, way beyond me, but at the end of it, they said, well, it should be something about there. And sure enough, a year later, bingo, they found it. Pretty much right where it was predicted to be. So first planet that was ever discovered that way. Yep. Okay, Jupiter, again, not too much to say. In the south in early evening, very obvious, very bright, pretty easy to observe if it's at all clear. The southern equatorial band is returning, but it's not real quick. I don't know, I didn't see Rolf tonight. Has anybody been observing the band returning? A little bit, anybody?
You couldn't see it through the clouds last night, but you could at least see the northern belt. But yeah, if it's there, it's still very faint.
Yeah. I had thought from the way they were talking about it last month that it was going to have progressed and you'd actually see a bit of a band by now. But it looks like the disturbance is getting bigger, but it hasn't really started to brown up yet, right?
Well, like I said, you could barely see anything other than the northern equatorial belt. So
Oh, yeah.
Like it's far from being as prominent as it used to be.
Yeah, fair enough. Okay. So, you know, stand by. It'll be improving over time, I guess. Okay. You know, once again, a little bit of a challenge. If you get a clear night and you're looking at Jupiter, see if you can pick out the disturbance. It's fairly close to the Great Red Spot, and you know, you may be able to see the beginnings of the southern equatorial band coming back again. Okay, Uranus, very close to Jupiter right now. That was January 2nd, as Gary was saying. Closest approach January 2nd, right? Yeah, something like that. And it was really close. But it's the last of a set of 3 conjunctions. They come in threes, and then there's going to be a long gap until we see another one. So it'll be 2024 before we see them real close together again. So, you know, it's kind of your opportunity if you haven't observed it. If you get a chance in the next couple of days anyway, you get a break in the sky, you might pull out the gear and see if you can pick it out. Okay? Magnitude 5.9. So it's beyond, you know, like naked eye. You're not going to be able to see it, but it's not a long, long way beyond naked eye, I don't think. Yeah, Gary?
It's also like a greenish blue fuzzy star.
Yeah.
It's not a very sharp star.
Yeah, yeah. So, you know, if you see it alongside stars, you should be able to figure out, oh, yeah, okay, that doesn't look quite like a star. A little bit disc-like, right? And the color as well will be kind of a giveaway. There won't be anything else like it around there. Okay. Locations of these ones, just so you know where they are. This is just after dusk tonight again. So you've got Saturn. Sorry, it's before dawn, just before dawn tonight. So Saturn, fairly high in the south, maybe even a little west of south. Okay, Venus. Well, it's pretty hard not to notice Venus, right? It's like a headlight in the sky. A lot of people mistake it for an aircraft, except it sits the same place for 8 hours. But what is it? Venus, very easy to spot, and you may well be able to spot Mercury. What's that, John? Oh, I thought you said something. Okay, fair enough. Mercury, southeastern, early in the month, greatest elongation, January 9th. So actually the best opportunity is just coming up for observing that. You know, like it only comes out a little way from the sun and then it starts going back again. So yeah, it kind of have this narrow window of a couple of days that you can take a look for it. But it's kind of an achievement to spot Mercury. There's a lot of people, surprisingly, who have never seen Mercury. So a reddish looking thing. And naked eye, of course. Okay, Venus, best viewing, greatest elongation, January 8th. So we got a whole bunch of these things that are all right in around the next couple of days. If you get an opportunity, you can take a look at. And very, very bright, right? Minus 4.6. Saturn, rise near midnight, high in the southern pre-dawn sky. So we're going to be looking at the north side of the rings in 2011. You know, kind of we get different point of view on it depending on the year as it moves around. So this year we're going to be looking at the north side of the rings. A little bit different looking. Yeah, Gary?
Also a major storm in Saturn now too.
Oh, I didn't know
Major
that.
storm.
Oh, okay. So
It's like a little squiggle across the storm.
oh, okay, okay. So if you get an opportunity, pardon me?
Not that.
Oh, yeah. Yeah, so rings will be tilted about 10 degrees. It's a decent amount, so you can see the rings pretty well. And magnitude is fairly bright too. You know, like you'll be able to see it naked eye. You'll know that's a really, really bright star or it's Saturn, one of the two. Okay, so a constellation. I've been thinking I'll kind of mention, you know, for every month, look up in the sky what's pretty much straight up and talk a little bit about what you can see up there. So this time, Monoceros or Monoceros, you know, depending on how you like to pronounce it, kind of like rhinoceros. The unicorn, right? Mono, single horn, that sort of thing. Okay, the unicorn, well, there's a whole story. If you watched Clash of the Titans the other night, you basically got the synopsis in a couple hours of the whole story. But there's a whole set of constellations up in there that are all involved in this story that was laid out in Clash of the Titans. It's basically Perseus coming back home and, you know, in the meantime, there's big battle between Zeus and, you know, the evil guy. What evil? I can't remember his name. But what is it? And the lovely Andromeda gets hung up, and the horrible creature, what is it? Cetus is coming to eat her, and all this. And Perseus brings out the head of Medusa and freezes him. It ends happily anyway. Anyway. Oh, sorry. Sorry. But what is it? Monoceros is the unicorn that Perseus rode back on, right? That's who he was riding. It's one of this group of different constellations that are all related to this tail. That's a lovely image you've got there, Chris. So Chris has kindly gotten us sort of the fanciful artist depiction painting, which, you know, are really nice to look at, but I've never actually seen one of those in the sky. That's, you know, it always ends up that it's a little bit of a challenge for you to translate from, oh, the unicorn, I'll just look up and I'll see the unicorn in the sky, and I don't see any unicorns. But, yeah, well, astronomers are known for their imaginations, I guess. So if we actually look at more like what it's look like, there's your sky. Okay, well, okay, where's the unicorn? Do you see the unicorn? Okay, I'll help you a little bit. First of all, you guys probably recognize, oh, look, you know those three stars, right? That's Orion's belt, right? And there's his sword down there, and, you know, knees and all that. Okay, so there's Orion right there. So what you do is you come a little bit to the left of Orion, and see that pair of stars there? Okay, we go 1, 2, zip, zip. Okay, you got that thing. And then there's some more of it up here. So maybe I can help a little bit with that. Here, is that better? Okay.
Never seen those lines in the sky.
Yeah, I never did either. But it at least helps with finding, you know, the stars that are involved in it. So there's, again, you know, as I was saying, there's those two stars. So if you just look left of Orion, you should be able to pick out those two stars and then just go zip, zip, you up, down, and up again. Okay, and the other way you got this little thing. So now you kind of know where you're looking at here. And oh, by the way, there's a really bright star down here. You know, so it kind of helps you to find where you're looking at. Okay, so in this constellation, well, this is one of the, you know, sort of the poor relative constellations. It doesn't have a whole heck of a lot of these, you know, like really bright jazzy things in it. It's only got a few things. So people usually pass over this and they talk about Orion, or they talk about, you know, anything else but this. But I thought, well, why don't we talk about this tonight? So what's in here to look at? Let's take a look. First of all, there's the boundaries of the constellation, so you can kind of see. It's considered, Monoceros is considered to contain everything that's inside this box here. And inside there, well, let's take a look. We'll just zoom in a little bit on that. And so this is kind of the more interesting stuff you can find in here. One Messier, M50 down here. So what's M50? Well, let me give you a little bit of info. It's also known as NGC 2323. It's about 3,500 light years away. It's an open cluster, and you can see the brightest stars in it with binoculars, but you kind of need a telescope to see the rest of it. But anyway, it's one of those fuzzy things that made Charles Messier real mad, so he wrote them down so he wouldn't, you know, be observing them. But anyway, we now look at them a lot. Oh, did I do that? Sorry, I got to back up here.
I'll back up, though.
Okay. Thank you. There we go. He's good at that. Okay, next, the Rosette Nebula is also kind of interesting. It's up in here. Okay, the Rosette Nebula itself is emission nebula, if I remember correctly. And it could be reflection. I think it's emission, though. What is it? And it has an open cluster embedded in the middle of it. That's also nice to look at. So the Rosette is a little tough to see, you know, through a scope by itself. You want to use like a nebula filter, and then you can pick it out. It's easier to see then. It's 5,000 light years away. There's also this NGC 2244 that's embedded right in the middle of it. You know, so you can kind of, once you find one, you find the other. And it's also 5,000 light year away. So, you know, it could be, if there's the same distance, then it's probably emission nebula, right? But if the nebula was further away, it's probably reflection and it's coming back. But I just don't remember. I should do.
Emission nebula, and the cluster is actually physically in the center.
Okay.
And the stellar winds are blowing out the bubble, which is creating a kind of a hollow cavity, and the nebula is just this big ring that's at least twice the size of the moon in the sky.
See, this is how I get him to talk at the meetings, right? Thanks, Glenn.
Make a mistake, you'll be caught.
Yeah, that's right. That's right. Yeah. what's it? So beyond that, NGC 2301. Okay, these are all really open clusters. So it's not, it's not the sort of planetary nebulas and the big glowing balls of stuff in the sky and that kind of thing. Monoceros is mostly open cluster territory. So the rest of these are open clusters as well. They're all they're observable with binoculars. To some extent, and with a telescope, they're all fully resolved. They're kind of nice to look at. So here you have this little constellation sort of tucked in between other really popular ones. There is some interesting stuff to look at in here, but it's not it's not like wildly exciting like a lot of the other ones are. So that's kind of it for Ottawa Skies. Okay. Well, thanks. And I'm gonna go on here right away with just a little bit of a dedication. We were contacted by a family lives over on the east side of town a little over a month ago regarding. Basically, their mother had passed away, and they were left with some astronomy equipment. Didn't quite know what to do with, so they asked for some advice from us. Well, okay, in the end, after discussing what they'd like to see, what they thought their mother would like, that sort of thing, we ended up coming up with a solution where we're going to engage the equipment in public outreach. Their wishes are that the equipment be used to enrich other people, to educate. They didn't really want them to end up in somebody's closet, but more, be used and benefit more than one or two people. So we've been able to work something out, and what is it? I just thought I'd say a few words, and we'll do a little bit of a dedication here. So this has to do with Susan Ann Manicom, who passed away in 2004 at the age of 85 years old. So I've got a little something that her son gave me, and I'll just read it out to you. It's a bit of a story. So Susan Ann Manicom, née Nickel, was born on a farm in Robertville, New Brunswick on April 14th, 1919. She died on April 13th, 2004, aged 85 years, at a nursing home in Cannington, Ontario. Her interest in astronomy dates from her youth on the farm, which at the time was miles from the nearest town. Since no one had electricity in the rural areas, there were no lights. I'm envious, right? And naked eye viewing was excellent. She spoke of lying on her back, looking up on summer evenings. She moved to Montreal to work just before World War II, married, and was a stay-at-home mother in Montreal and Quebec City. She was always interested in astronomy and read about it. However, buying a telescope was simply not a financial option. She and her husband moved to Pefferlaw, Ontario in 1972 after he retired. She acquired her first telescope, a Newtonian reflector, in 1979 at age 60. Her husband made her a concrete pad in the backyard, and since the municipality had recently erected streetlights in the semi-rural area of their home, she petitioned the municipality with the support of her neighbors to have the streetlights disabled, reducing the interfering light. Shortly after this, she found her grasp of mathematics too weak to fully understand astronomy, so she returned to high school and took math courses to brush up. She read Sky and Telescope, acquired and used reference books and star charts. She was always tuned in to any current phenomenon in the heavens and rarely missed an important event. While she talked to others about her interest, it was one she pursued alone. None of her immediate friends had more than a passing interest. A deeply religious person, she also regarded viewing the heavens as appreciating the scale and beauty of divine handiwork. We're unsure of the date of acquisition of her Meade Schmidt Cassegrain. It was likely about 1993, since she inherited some money about that time and wanted, for really the first time in her life, to make a significant purchase in direct support of an interest that was exclusively hers. The Meade had extensive use, and she gradually acquired various accessories and eyepieces. She kept diligent logs of her viewing activity and continued her observing until about 2000 or 2001 when illness interfered and eroded her interest. As far as we know, the telescope was unused but carefully stored from that time until now. So the couple of photographs that we were looking at there, the first one was her walking in the snow Christmas Day 1974. So that's at the age of about 60, I guess, something like that, Pefferlaw, Ontario. And the excuse me, the second picture was his father aligning the spotting scope on her Newtonian reflector in 1979 in Pefferlaw. Interesting mount. That's a horseshoe mount, I think, if I remember correctly. Anyway, so, you know, at the end of all this, what's it all about? We've been gifted the center with her Meade Schmidt Cassegrain telescope that they've requested that we get involved in public outreach astronomy. So I'll just show it to you. Did you get the links there?
It'll come on its own.
All right, thank you. Here we go. And quite nice condition, nice tracking unit, should be excellent for astronomy, public outreach stuff. And we've had a plate etched for it, which you can see here. We've got a reprint of it.
Yes. Great idea.
Good idea. There they are.
I'm delighted.
Thank you very much. Okay. So, oh, by the way, I should probably mention, just, you know, you might wonder, there's a little bit of scripture at the bottom there. And, okay, why that? Why that in particular? Well, when I picked up the telescope, it had a little card attached to it that she had taped on it God knows how many years ago. It was the masking tape was pretty crispy, so it was probably a good 10 years or more ago, probably a lot more than that, and that's basically what was on it. So she had it there to remind her whenever she had the telescope out, a little bit of a reminder about, you know, what she was looking at in the sky, as was said, very religious woman. So I thought it appropriate to have this transcribed onto the plate, sort of for posterity. So, okay, so without further ado, next up is Sylvie to give us the 10-minute astronomy news. Sylvie, welcome.
Okay. So I'm trying this for the first time, trying to have my two hands. This month, my talk will vary from the tiny, tiny, small microorganism to the big, big supernova. So, isn't that what I'm supposed to click?
Right-hand button.
Yes, I knew how that works. So this is to set the tone to the arsenic bug topic. I didn't bring any hors d'oeuvres, but I thought of doing that. Maybe nobody would have liked to try them, though. So, there we are. And so the arsenic bug's been talked about a lot. It's, to put things in perspective, it's a NASA-funded research involving a researcher named Felissa Wolf-Simon and a bunch of other people, and one of the head is Ronald Oram Land. I'm not sure if I pronounced his name properly, but anyway, we'll see them a little later on during the presentation. So they're not nobodies, and there's a reason why I say that. They've been a little picked on. So this is Mono Lake, where the research has taken place. It's in California. It's been picked because it's really high in salt. It's got a very high alkalinity. See, I cannot say that word either.
Alkalinity.
Thank you. And a very high arsenic level. Wait, did I get to the rest of my presentation? So that's why they picked that. While you're staring at this lake, which is full of arsenic, so not a very nice vacation place, I'd like to review some of the basic of and that's where I'm talking about something I know nothing about, which is not very much different than usual. We're talking about astrobiology, microbiology, biology, really not something that I have a lot of expertise in, but let's just say that in biology, the 6 basic blocks of life are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And phosphorus is a big part of the chemical backbone of the DNA, RNA, IRS, RA, oh, FBI, CIA. Oh, sorry, I got a little too much crazy here. But what it is phosphorus is a central part of all living cells, whether it's the nucleic acids, the proteins, or the lipids. Even if we don't really understand how those guys form life, if you don't have that background, what's important is that phosphorus is part of everything. So arsenic, as we know it, is poisonous to most life on Earth. And all we know is that, up so far, we knew that a few microbes are able to breathe with a TH, which I pronounced not very correctly, so it's not breathing in reproduction, but breathing in arsenic. And so that's what we've had. But now those NASA scientists have a new microbe, which actually is a bacterium, but anyway, let's just call it the GFAJ1. And this new guy in the lab, so it's been taken out of Mono Lake in the mud, it's been brought into their lab, and it's already got a lot of arsenic in it compared to other lakes or other samples or anything else on Earth. So it's living with arsenic, but what they've been doing is they've been removing the water and putting water in that had less and less phosphorus and more arsenic in it. And that bug continued to grow with the arsenic and less phosphorus. So that's the first known microorganism that's able to thrive and reproduce using the toxic chemical arsenic. So their claim is that it's been able to substitute arsenic for phosphorus at the cellular level. So the key issue is that the arsenic is supposedly incorporated into the microbe. But, and there's a question, is the arsenic in the DNA, the lipids, the proteins, or the nucleic acid? Is it part of the microbe itself? And that's where everything sort of starts to get a little more iffy. These people, so there's Phyllis to the right, the left, sorry, and Ronald to the right, and those people and their teams say, yes, we think so. This microorganism is building itself out of arsenic. So in its DNA, it's replacing the phosphorus for arsenic. Now, the controversy is, and where things start to be a little, messed up. First of all, when NASA announced or did the pre-announcement to the news, there was a lot of people going off and saying that they had found aliens and other things. So no, we're not talking about life on another planet. We're not talking about an alien on this planet. We're not even sure we're talking about an arsenic bug at this point. But we raise a question, maybe what they're saying is maybe life could exist without the phosphorus and just the arsenic if it's able to replace it. But for sure, that bug seems to be able to detoxify the arsenic and use it to survive. So it's adapting in extreme conditions that we may not have thought of for astrobiology. But again, there's the question of, does it really replace the phosphorus at the DNA level for arsenic, and what are the evidence? Other people, other researchers says there's no evidence of that, although these guys say, yes, there is. So whether or not the arsenic has been integrated, what seems to be the thing that everybody will agree on, and here we'll put that little microbe back there, is that the results that they have, and nobody's sort of contesting that, is that the arsenic is very close to the DNA close enough to be associated to it, but they're not sure if it's really part of it. Other word, is it contaminated or not? The chemical structure change has not been proven, but the arsenic is there and it's very close to it. So in conclusion, those NASA scientists are wanting to work with more scientists, do further tests to prove that there are in the right line and that there is a chemical structure change, and they're offering to make their cells and DNA samples available to others. But for sure, in the meantime, what NASA has been saying is this expands the definition that we have on life to a scope that's a little broader, and our research for life beyond Earth has been modified because we never thought of looking or thinking that if we found arsenic, that there could be something living there. So that's the main conclusion to that discovery. Maybe you later will have a little more detail on what happens and whose was right. Now, my next topic is this young Canadian girl who discovered a supernova. Her name is Catherine Aurora Gray, and she is 10 years old, and that makes her the youngest person to discover a supernova. And as a detail, she lives in Fredericton, New Brunswick, or very close to there. And here's the story for people who may know some of these guys. Basically, David Lane gave her father, Paul Gray, a picture of the galaxy UGC 3378, which is about 250. Sorry?
It's in Camelopardus.
Oh, thank you for saying I had that word for me. I was not sure how to pronounce it. Thank you, Paul. That's great. So, like he said, it's in that constellation, and it's 240 million years away. I'll drink to that. He took the picture on New Year's Eve this year in his observatory called Lane Abbey Ridge, and I think it's in Nova Scotia. Maybe somebody will correct me on that. It's not in New Brunswick, I don't think. In Nova Scotia, okay. So Catherine used a comparing software, and I was actually, this is the supernova, but I'll come back to that. My slides were not in order. When you see the blinking spot, you tell me. So she used a comparing software which will basically compare the difference between the previous picture and the new picture, the recent picture. And if something is not on the older one, and it is on the newer one, it appears as a blinking spot. And there's the blinking spot. So if I have... Okay, I did something. I hit the wrong button. What else is new? Okay, help.
There. Don't hit the top button.
No, okay, and where's the pointer?
In the middle.
One of those days I'll get these right. Okay, so for people who have not seen the blinking spot, this is my left hand, this is not very stable, but there's the blinking spot. Okay, somebody else is pointing. Oh yeah, there's something else there, but this is not it. If we just go back to the other, you can see that this is the galaxy and the supernova is right next to it. So what you're pointing up there, I don't know what it is, but that,
maybe a cosmic ray hit in an image.
Oops, sorry. Who knows?
Another galaxy.
Another supernova. Maybe we just discovered another one she didn't see. Yeah. So it took her about, once you start looking at the pictures, only 10 to... Another one on the bottom? It's a software glitch. So when she started looking at those pictures, in 15 minutes she had seen that blinking spot, not the other ones. And put things in perspective, some people that are hunting for supernovas, they can look to thousands of hours before they make such a discovery. But it seems in her family, they're pretty lucky, because I'll tell you how many they have, and it's not the first one. So she showed her dad that little spot, and so he went through the list of existing supernova and looked out for asteroids or anything else that could have been in the sky, and he said, no, I think it's a supernova, and then voila. The discovery was verified by 2 other amateur astronomers, Brian Tiemann in Illinois and a Canadian, Jack Newton, in Arizona. And so then the discovery was registered and later announced by the RASC in Toronto as the supernova, 2010 LT, and it's of magnitude 17. And so, like I said, in their family, it's quite a thing. For her, it's her first one, but her dad, she shares the discovery with him, and it's his seventh. And David Lane, for him, it's his fourth. So they have already quite a few supernova discoveries in their family.
One thing I haven't heard of is how many images was she looking at before this one popped up before?
Well, I don't know how many images, but that was after 10 minutes only.
Now, call me a cynic, but I can imagine some dad saying, oh, here's something that looks good, put it down, and have the kids say, okay, look for the blinking light and point it at.
Okay, he's worse than me. I thought of very, very interesting thoughts, but well, okay, maybe, we'll never know.
This here now is setting a record. Now I can see a 5-year-old perhaps sometime down the pipe that's going to find one.
Well, actually, we have one father in the audience who has a 5-year-old who's very interested in starting to do that too. We won't name him. So there's been a lot of talk about this. Supernova events are considered rare. They're not like eclipse. They don't happen all the time, but they do happen. And if you take the time to look, you might see one. Some people like hunting for them. And I guess because she has already been exposed to her father and her father's friend to hunting for supernova, that's something she decided to do. So she is young and she's showing interest in astronomy, and as a person who really like doing that with kids too, I think it's great, and I think it's a good thing that, or very nice for her that she's been rewarded so easily, so fast for her interest, and maybe it will help other young people, not necessarily younger, but young people to show interest in astronomy. But I do have the warning, because when I do go to school, and now that this happened, I might get asked, how can I look for a supernova myself? Well, you have to put things in perspective, and I don't mean this to take anything away from her, but she did not do the image herself. So you have to know somebody who will image the sky. You have to have the previous picture, and then her dad did show her the software to compare. So there's more than just sitting in front of the computer. So if you think that anybody could have done it, or if you have a kid who wants to do it, it's not that straightforward. You have to have the prep done for you. So, but still, in 15 minutes, so I don't know how many images that was, Glenn, but she is a very, very lucky girl. And the other plus that I saw to this is that when I read the news articles on different websites, as the RASC was mentioned, so we got publicity too out of that. So that's great for me, us.
Sylvie, that galaxy UGC 3378,
Mm-hmm.
it's a 14th magnitude galaxy. So you have to have a fairly good telescope to see that.
Yeah, you are right. It's not. It appears very bright there, but that's.
No, 14th magnitude.
Yeah. No, you are correct. Well, and you can see the supernova is 17, and you can see it next to it. It does look brighter, but it's not that much brighter. It's not. Yeah. And I don't have such a telescope. So I'd like to finish this talk, which has been going on again a little too long, with some publicity about something I discovered, this week. I didn't know this thing existed, so there might be a couple more people in the audience who do not know that we have discussion lists with the Rasc, and in particular that national one, the Rasc goals. And so I just wanted to point out that it is possible to subscribe to those distribution lists and get emails about what people talk about, sometime when news pop up or whatever. And there's a very I found obscure way to get to there through the RAC main website, going through the programs tab. Why a program, anyway. And in the left column, there's an index And yeah, there is words missing in my slides. That's okay. And then there's basically a link that you can choose that's called National Email Discussion Groups, and there's a bunch of them, but in there you have a choice for the rascals. And then after you subscribe and the moderator has accepted you, you get bombarded with tons of emails every night. Thank you.
Thank you, Sylvie. So next up to talk to you about public outreach is Moghadam.
Hi everyone, and hi as well. Welcome to the folks who are new tonight here. That's it's always nice to see you. And I wanted to say just for 1 minute, I've been involved with outreach, and it's a real pleasure to see a lot of particularly enchanted youngsters who are looking through a telescope and seeing the rings of Saturn, or seeing things that some crater and detail on the moon that they hadn't seen before. This gift from the Moghadam family is a special gift, and it's a wonderful, beautiful legacy, and I can tell you it's going to make a lot of youngsters very, very happy. So thank you again. Okay, I'm going to talk to you a little bit about some of the recent outreach events, some new stuff coming up. Eric is going to come and talk about, Eric Ajula is going to talk about an event he held in November, and some other announcements I've got as well. We're privileged to be invited by the museum to several events. One of the events that they invited us to recently, and they invite us every year, is the Winter Solstice event. And often this event, the weather doesn't hold up very well in December. And sure enough, it was the recent event that we had just past December 21. It was cloudy, and you never know how many people will show up for these events. We had an indoor exhibit. Tim Cole was manning the Helen Sawyer Hogg Observatory. And it was actually, when I was driving to the event, there were some snowflakes coming down, so I thought, oh my goodness, how many people can we expect? There was over 60 people that showed up, okay? And they showed up actually before we started the event, and they were waiting for us to get going and get started and so forth. Jeff Cohill, Sylvie Létourneau was there, myself, and of course Tim at in the observatory. And we had Jeff brought some instructional videos. He had a group of people that were watching them, and Sylvia and myself were behind an exhibit. We were giving out items and so forth. Went over very well. We had people that stayed for quite a while. The museum events always surprise me, okay, and they're always a pleasure. The next one that's coming up, well, actually we have a couple of events coming up. The one that we have every year, as well as the Astronomy Day event that we're invited to, in the one in April, May timeframe, and I'll be announcing that one in a future event. It's usually a very popular event as well. We're invited for usually daytime and evening, and there's also an indoor component as well. So stay tuned for that one. I don't have a slide about this one, but I wanted to mention this just because I just got the request just yesterday, in fact. The museum is celebrating Earth Day, which is Saturday, March 26th, I believe. And they're planning a star party as well, public star party. They've asked if we could join them with our members, bring our telescopes, so that folks from can look at the night sky. It's going to be interesting because the museum is going to be, lights are off indoors, so they're planning some sort of candlelight events. So the details are just sort of under development right now, but I'll keep you posted. So it sounds like it's a new event, and obviously Earth Day Earth Hour, I should say, is built more and more momentum every year. Okay, actually, why don't you do it, Chris? So we had an event recently, a school outreach event, which we didn't talk about last time, but Eric and Eunice Kajula organized the event, and I thought it would be great if you two spoke to it. So Eric?
Hello everyone, Happy New Year, Bonne année. November 19th, I had a lot of fun. We did another outreach at my children's school, Pierre, Elliott Trudeau School in Gatineau. And we started the event with a slideshow, and I as the videographer here, I get to accumulate all kinds of little goodies, slide animations and things, which I make use of for these outreaches. And where I can, I will ask permission from people who've taken photos here to use them as well. And we did a slide. I did a slideshow which I prepared on DVD, showed on a projector, and they were very attentive. They were great. And one thing you might notice is that most of the students are girls, which I thought was fantastic. You know, I mean, everyone's welcome, obviously. We had 26 parents and 24 students attend the event, which was the biggest turnout so far for me. And after the slideshow and the presentations I did, we did a tour of the solar system. You know, it's a really good thing also to engage those that you outreach to get them to talk back to you, to ask questions, and you know, to give them the opportunity to express themselves and how they see the universe, which I found very interesting listening to them. You just need to take the time to do that, which I did. And they had some very interesting comments to make as well. For example, they were very much in tune with the planets and the fact that the Earth goes around the sun. You know, for a 6 or 7 year old, that's a remarkable thing already for them to understand that, because we take that for granted. You know, it's ho-hum to us a lot of times. But for them, this is all new stuff, and for them to actually grasp the idea of an orbit was very interesting. And when I would speak about something, I would ask them a question, and they were really very responsive. They could understand what I was saying. I don't water down the information too much. It's very important to remain scientific in your explanation, but you have to be careful. And so I created a balance there so that they could still understand what I was talking about. After the presentations, can we flip to the next slide? We did some hands-on. And thank you to Jeffrey, who's here tonight, and Gordon Webster, who brought their telescopes and who gave these students, and I call them students instead of kids. You know, it's important to take that approach. They're students. And give them the hands-on. A lot of them had never seen a telescope before. You know, again, we're so used to it that, you know, we think, oh, but for them this was all new stuff, and it intrigues them. They love seeing the hardware, you know, real stuff, and people who know how to use it and to try it out for the first time. If we could go to the next slide, please. Then we went outside. Now, obviously, November 19th, if you'll remember, was not a very good night. A lot of clouds, but the moon did make an appearance, just enough for them to be able to see an object in the sky. That's all that matters at first, is just give them something. And we were very lucky to be able to get the moon. And they remarked that they had never seen the moon this way before. You know, through the glass, the detail that they could see, you know, is very different from looking at a picture of that. And they loved it. They just loved it, you know, and they stayed on it as long as they could. And by the way, Gordon gave me heck for using the flash on the camera. Takes away your night vision. But next, do we have another slide? Okay, so that's it. So basically, great outreach. And this new instrument that we have here, I hope to be able to make use of it with these students and outreaches that I'll do in the future if it's available. And I'm also interested in the logs and all the data that Mrs. Manicum had, because that is also something that should be put into the RASC archives if it's available as a copy of those logs. That's a lot of work that she did, and it has to be preserved. And we can even take a look. Yeah, and we could show that to the students as well, to say, here, this is what you do when you observe. You log what you did, and so on. So great. And this coming year, what I'll be doing more of is class presentations instead of this was done in a gym in the evening. I want to engage the students more in the classroom on observing and astronomy in general. And I also did talk a lot about the RASC itself, to explain to them that there is a place you can go to engage in astronomy with other people. And you'll learn so much, and it's to enrich our lives. This is what this is all about. Thank you.
Thanks, Eric. A couple of announcements I want to make about the outreach program. I'm pretty excited about the outreach. It is a growing program. Let me talk about a couple of the changes. First, for the CARP public star parties. For those who don't know, our center hosts public star parties in CARP in the CARP library. In fact, the Diefenbunker site is a sort of a very well-known location. It's far enough away to be away from the worst of the light pollution, but not too far of a drive as well. We host these in the spring, summer, and especially fall. Last year we had 8 star parties, and I think we went ahead with 4 of them. The Skies cooperated with 4 of them. Stephen McIntyre is going to be scheduling and coordinating that this year, and I'm really excited about that because he seems to be better at calling making the go/no-go calls than I do. Whenever I make them, it seems like they don't happen. When he made them, they happen. So I feel good about that. Thanks, Stephen. As well, another big development is Sylvie is taking on the role of school outreach coordinator. So there's really an opportunity here to grow our outreach. Sylvie, I was talking to her over dinner. She's got lots of ideas, lots of energy, and you're going to be hearing more about her in the coming months. But definitely some really good ideas and some positive developments there. So I'm excited about that as well. Thanks, Sylvie. Next slide. More specialization. Chuck O'Dale is helping out with Science Fun Fest. We all know that is our big event of the year. A monstrous event, takes a lot of planning. Chuck's offered to coordinate that, and I'm going to help him as well because it is such a huge event to plan and organize. But I appreciate Chuck stepping forward on that. Every year, we've done that, as you recall, 2 years in a row, and it's gotten quite big. I'm excited to see what next year brings. So I'm sure we're going to be doing something even better next year. I am stepping back from the outreach coordinator position, so that brings forward an opportunity for anyone who would like to come and sort of into this role. I think we probably could use, there's a great opportunity for some new ideas. But I'd like to say that I'm not stepping out of the picture altogether. I will be sort of in a support role. I've enjoyed outreach way too much to sort of leave the picture altogether. Okay, but there is an opportunity here. If someone is interested in this, perhaps you have some ideas from when you were when you were all younger, and you perhaps encountered someone who sort of shared the wonders of the night sky with you, and you want to sort of bring that back into our outreach program, and or launch a new initiative, a passion of yours. Let's do it. Here's an opportunity, okay, to organize that. So lots of opportunity here. Next slide. Sort of to build something else I wanted to announce to sort of build on what Sylvie was talking about a national email distribution list. Our center has a email distribution list that is open to all members. Okay, and it's a wonderful opportunity. So if you are a member of the Ottawa Center, you can receive emails sent from other members, and you can also send emails to all members that are subscribed to this list here. So some of you may not be receiving some of these emails, and by the way, what are the kinds of emails that come on these in this list here? Usually, we send out emails bugging people about outreach events, reminding them about outreach events, the go/no-go calls, and so forth. Maybe there might be some special event coming up in the news event coming up. Bill usually announces the meetings and call for presentations and so forth. So it's a great way for our members to communicate with each other. If you're not part of this email distribution list, will you just maybe see me in the break, and if you want to be added to it, let me know. We can add it, or you can see Richard McDonald as well. But it's certainly open to all. Gary?
Just to mention, too, we're also on Facebook now, too.
Oh, good point.
Great way to get the message out right away.
That's an excellent point. Yeah, as I think we said last month, Gary, you're the spearhead of that on Facebook. So excellent. We reach another crowd, that's for sure. All right, I think that's it. Thanks very much, everyone.
There we go. Next up, just a brief presentation, Peter Heyman, to talk to you about the Carleton University Astrophysics Society. Peter?
Okay, well, I don't actually have that much to talk about it to describe better right now. Still very much a work in progress. For most of my efforts with the society for now have been directed towards being able to hold public start parties with the school observatory. But that progress has been pretty slow in that, mostly due to a very uncooperative physics department. It's great for physics there, but not for astronomy. So I'm still working on that, and I have been making some progress, but in the meantime, I'd like to try and still keep interest in the society and in astronomy there. So I was trying to think of some other activities to do, and I thought about the RASC meetings and about the great presentations that we get here. So I'd like to ask anybody who has any ideas for presentations or any other activities or whatever. If you're interested at all, anyone here. That's the, actually it's just one P in CUFs. Carleton University Astrophysics Society. That's the email. Let me know or talk to me afterwards.
It's crowding in on Chris's talk too. The two apps.
That was my typo. You know why? Where my mind was.
Yeah. So, oh yeah, the website is at physics.carleton.ca/CUAPS. Thank you. Yes, I've actually, Mike has been very helpful.
Did you speak to Peter Watson, Professor Watson?
Yes, actually I do.
He's very friendly with us. Has been for many years.
Yeah, actually the thing is, I've got the support of pretty much everyone in the department. The only person that I don't have the support of is the department head. And he's the guy that can give out the key and the permission. So I even, after quite a bit of effort, managed to get the safety coordinator's permission. So yeah, it's down to that. But that's going to take quite a bit of effort, and I really want to keep interest in this. So the physics department does do these guest lecture things, and I thought it'd be a good idea to try and have them more astronomy related, because they do some recent physics stuff, which is great, but there's just not much astronomy there, even though there's a nice 14-inch telescope. So I want to bring it back. Thanks.
Let's see, observations. So our popular part of the program where members from the audience can come down and tell us about how they captured wonderful pictures of the stars. So for tonight, we have Paul Commission, we have Sanjeev Sigril-Rasa, we have Bob Olson, and we have Eric LeMay. So, getting right into it, Paul Commission. Paul, would you like to tell us about your photo?
Yes, this is NGC 1333, a bright nebula in Perseus. This is located in the south end of Perseus. It's in the Perseus OV2 Association, about 1,000 light years away. You'll notice at the bottom there's a large lane of dust, a little bit there too towards the middle. Len tells me he can see this thing at a 60-millimeter binocular. I have not tried looking at it through a binocular, but this is an 11-minute exposure with a B14.
Len has a good enough
I'll try it one of these days. I have a 70-millimeter binocular. I'll try it.
Thank you, Paul. Okay, next one up, Sanjeev.
Hi everyone, happy New Year. So I brought up the pictures, and what they have in common is that I shot them all with camera lenses, as you know, I picture with camera lenses, as well as telescopes. So each lens that I'm going to show you the pictures with, the optics are pretty small, so each right lens weighs about 2 pounds, and they're going to range in focal length from 24 millimeter lens to 135. So So this, the first picture here is, I took this in October at Mercury Campground in Algonquin Park. It's about 2 hours from here. It's actually one of my favorite campsites. And this picture, the total exposure here is just 60 seconds. It's a tripod mounted photo, like just a camera tripod. It's not in the tracking mount. So, in fact, it's only 30 seconds because what's happening here, this is a mosaic. So I've shot 2 pictures and stitched them together. Okay, one here and one here. This is a 24mm lens on the Canon camera, full frame camera, 5D Mark II. This camera I didn't modify. It's not filter modified. If it were filter modified, you would see a lot more reds here. You can see the horse here, right? And you see this? This is the central bulge of the Milky Way. It's setting. This is around 8 o'clock in October, and you can see here, this would be a lagoon nebula. Normally it would be very pinkish, but because my camera is not filter modified, typically with this camera I would get more browns and yellowish colors. And believe it or not, there's a bit of, you can see a bit of sky glow. This is a pristine sky to the naked eye, but I don't know where this is coming from. It could be coming from as far away as Toronto. It's really, this is the southwestern horizon. We're looking at Grand Lake here. And I want to do this kind of photography for a while. I just didn't have a chance. I like this camera for nightscapes because, you know, I can get a pretty realistic representation of the landscape with an unmodified camera. And I left these markers on the beach in the swimming area because we took our kids swimming here. This is the first campground where they went camping 2 years ago, when my son was only 3 at the time and my daughter was 5. And these markers, kind of a good reminder of what this area looks like in the summer because it's a lot more active. There's a lot of kids. But in October is a good time to go for shooting pictures just because there's very few people. So,
Sanjay?
Yeah.
Would you mind if I just point out a couple of interesting features?
Oh yeah, sure, go ahead.
Okay. Right in here, we can see an interesting extension of dark nebulosity that extends far away from the plane of the Milky Way, well out into the constellation Aquila. Here's the bright star Altair, one in the summer triangle, and the body of the eagle kind of runs down this way, and its wings stick out. And this dark nebula, running almost perpendicular to the galactic plane, was almost certainly blasted away from the midplane by some ancient supernova explosion, forming what are called these chimneys. And it causes dust clouds to kind of get blown upward and forming these big kind of almost cylindrical walls. And you can see all kinds of them in other galaxies as well, like NGC 891. A nice edge-on galaxy has all these dark fingers that are sticking up perpendicular to the plane. If the galaxy is this way, all these little dark wigglies. And this is kind of an example of the same sort of thing right in this picture.
Yeah, I don't know if you've seen my, thanks, Lynn. I don't know if you've seen my, I have a similar shot to this that I did using 6-minute exposures. And I showed it at a meeting a while back, and I have it on my gallery, but that picture actually shows a lot more of the dark extensions you're talking about, because this one, you know, I didn't stretch this image very much because I wanted to preserve the landscape here, but if you, with my 6-minute exposures, I did a 2-frame mosaic going this way, and there's a lot of this very unusual looking stuff, like dark black stuff sticking out in different directions from the galaxy.
What was the ISO on this one?
Yeah, I was going to get to that in a sec. Yeah, that's I shot as ISO 3200. Again, because of short exposures. But interestingly, I shot dark frames, but I didn't use any. So I didn't find the noise level to be objectionable, so I just left it without any dark frames.
Remember what aperture you were shooting at?
Yeah, it's f3.2. It's an f1.4 lens. It's a Canon 24 millimeter 1.4 lens, the Mark II version. I always top it down to at least f3.2, sometimes f4, just to get the corners right. See, because when you're doing a mosaic, what happens is, like, it's not just the corners up here, right? Also, there's a corner around here and a corner around here. So you want to make sure that there are not too many aberrations in the middle of your mosaic, because you're going to have to stitch them together. Okay, enough about that. So this is in December. I shot this with a 50 millimeter lens at FLO. And this is out of Orion, of course. And I was trying to see if I can get the Bernard's loop, and I got it here. Now, the star atlases usually only plot this part up here, the brighter part of the loop. But if you go on the web, you'll see a lot of images of Orion where this whole area is really stands out a lot, and you can do that in processing. But I wanted to preserve the stars because I like seeing the stars in my photos. You can see there's the Horsehead down there and the Flame Nebula. There's a belt of Orion, of course, a sword, and there's Rigel and Betelgeuse up here. This shot kind of looks like it's easy, but it's actually, this is my third time trying this. And the problem with this shot of 50 millimeter lens is that there's often a lot of sky glow that interferes. So here what I did was I took 4 6-minute shots and 4 6-minute shots and 6 4-minute shots. That's what I did. 6 4-minute shots for 24 minutes, and then I did 6 1-minute shots, right? And then I combined them. So that allowed me not to blow out this area too much. But the other thing that I did with that is I actually blended this whole area down here to get rid of the sky glow. Because in my previous attempts over the past year, all this sky glow would always be a problem down here and destroy my shot. So that's what I did. That's half an hour exposure. And this is with my filter modified camera. It's a Canon 40D that I've got filter modified. It's a DSLR. And you can see it's got pretty good red sensitivity to be able to pick up all of the Bernard's loop.
Did you know the Witch Head is showing up as well?
Yes, it is. And that's a good pick because that's where we're going right next. So the Witch's Head Nebula is right here. Okay. So this is Rigel. And there it is. Now in this, what I did in this composition is I rotated it upside down because I wanted to show it. I like this composition better, but really it's that this nebula is really just slightly to the north and to the east. The thing is, this shot I did at Nirvana, so which is a very dark area, just north of Quantico Provincial Park. This is on October 8th. And October is a wonderful time to be shooting Orion because there's no snow on the ground and you can still handle your camera and the cables aren't freezing. But of course, this is the early part of the morning, so this is around 5 a.m. That I shot this one, 4:35. And Rigel is one of the most luminous stars in our part of the galaxy, and it actually has a double that I'm sure many of you have seen. Even in a small telescope with my 3-inch refractor, I've split Rigel at about 80 times, because the primary is so much brighter. The separation is about 9 arc seconds. Like in a photo, we just won't be able to see it because this area here alone occupies about a degree of sky. Like you're looking at about 7 degrees of sky here, right? This is my 135 millimeter lens, so the glare from the star is blocking out any chance of seeing the secondary. But with our eyes, at the telescope, the amazing thing about our eyes is that the dynamic range of our eyes is so great that we don't have a problem differentiating between the brightness of the primary and the dimness of the secondary. Now this.
Worth mentioning too that Rigel is the star that's lighting up the Witch Head.
Yes, that was my next thought.
Oh,
but thank you.
I thought you were getting ready to go to the
Well,
next page.
No, but I'm glad that you're getting this out of the picture because this is what I was hoping that the picture brings out. Rigel is believed to be about 900 light years away from us, and it's such a bright star that they think that the theory is that it's lighting up this area. This is a reflection nebula. There's a lot of nebulosity in this whole area here, and this is IC 2118, and it's thought to be illuminated by the light from Rigel. Okay, so the last shot I'm going to show you is another mosaic. I just want to see something here. The colors are kind of washed out on the screen. But anyway, this is I shot this at Nirvana as well on October 9th. And this is with my 135 millimeter lens, and it's a 2-panel mosaic. And what I was trying to do here is I'm sure you heard of this phrase, the Orion molecular gas complex. And it's believed that many of these deep sky objects that we look at in our telescopes are actually all part of the same complex of nebulosity, really. There's the Orion Nebula, there's the Horsehead and the Flame, and M78 up here, and this is the Bernard's Loop as well. That really, all of them are supposed to be at about a similar distance of about 1,500 light years from us, so they're all part of the same kind of complex. But this is about 9 degrees of sky, And I don't know if you can see in this picture, but I know on my monitor screen I can see it. It's all of this stuff here, this sort of mucky stuff. Can you see all of it?
It's got a kind of a brown hue to it.
Yeah, yeah. And it's kind of easy. You can sort of believe that it is all part of the same thing. So now to do this, I'm just going to go back a couple of shots here. Okay, so Orion, when it rises, that's between 2 a.m. and 5 a.m., right? So if you had a pristine sky, one of the advantages is you can shoot pretty close to the horizon because there's not much sky glow. So what I showed you there on that picture was actually this area here. If you draw a little box, right? So I first had to shoot this area here, and I overlapped it with this area here. So I put my belt stars in both my frames, because you need a bit of overlap to do a mosaic. And so when Orion was rising, it's kind of on its side. And then when at 4 a.m. you're doing the second set of shots, it looks more vertical. So it's a bit of a challenge to make sure that you've got enough overlap between your two frames. And then when you get home, you don't want to find that there's a gap, because then you're screwed. So that's one of the things about mosaics that I enjoy, is that the chance for failure is higher. So it makes it a bit more challenging and hence a bit more fun, because you really don't know after you've driven all this way and you come home, is it going to work or not? Just to give a bit of detail on this shot, this is a total of just under 3 hours of exposures. So I used 4-minute subs, and each panel has 20 shots, 4 minutes each, at ISO 800. And then the second panel is a composite, because you can see this is not blown out. So what I did here was on this panel, I used the 4 minutes times 20, but I also used 12 1-minute exposures and 12 10-second exposures. So then after I did the composite here, that's when I stitched my two panels together. And that's it, unless there's any questions.
Maybe a couple of comments again.
Yes?
I'll just get up so I can point here. All these dark brownish colored clouds, that's the dust-filled molecular cloud material that is the stuff from which stars are made. And it's estimated that together, these two subgroups of these clouds have enough gas in them that if you could convert it into stars, it would make probably something like 500,000 to perhaps as many as 1 million stars like our sun, just in that very dusty, dark gas. And in fact, the Horsehead Nebula is just like a little thumb sticking out of the cloud along the very edge. And it's just the bright red nebulosity here that the Horsehead is silhouetted against. That's just the illuminated edge of this actual cloud itself. And in the vicinity of the Horsehead, it's this star in little small cluster, Sigma Orionis. The ultraviolet radiation that's spewing out is illuminating the edge of the molecular cloud, and the stellar winds are also pushing away and sculpting the cloud, shoving it back, and we just have this very denser extension that's sticking out, that's resisting the stellar winds and radiation pressure that's trying to gradually erode and move the cloud further away. Barnard's Loop, which you see running around the left edge here, that's really just the outer edge of a shell from one or more supernova blasts, probably something on the order of 1 million years ago, that would have been centered in around the whole belt and sword region of Orion. And that's just kind of like a fossil remnant from this ancient blast that's continually expanding outward, but slowing down as it plows into the ambient interstellar medium. That's about all I can think of for now.
Thanks very much. Yeah.
I was also going to say that you can see how in the brown area, how few stars there are compared to the area just to the immediate to the right. That
yeah.
Clearly there's a lot of obscuration there, so there's...
And I'm very happy to hear that comment, because one of the reasons you can tell the difference is because you can see other stars. And this is the thing that you have in astrophotography. I think you have a choice, right? You can choose to emphasize the nebulosity, and there are techniques for doing that. Often with the CCD camera, when I use my CCD camera, that's what I'm going after. But with the DSLR, I find that I can represent the star fields a lot better. So if you don't see the stars, then you can't really tell that the other stars are being obscured. If all of your stars are being obscured, right? And often when this area is represented in photos, astrophotos, you'll find that there's a lot of emphasis on the nebulosity and not enough emphasis, in my opinion, on the stars. Sorry, there's another comment there somewhere?
No, I'm just wondering, how do you get your focus so sharp?
I focus manually. So I take the lens. The lens has a aperture, has a manual focus ring on it, and then I use live view on my camera, and you just pick. Yeah, so you pick any bright star, and in this field there's lots of bright stars. And you just make sure that they're as small as possible, as small and whitish as possible. I often just use the 5 times magnification. I don't use 10 times because I find that the star dances too much because of the seeing at 10 times. But at 5 times, and then you just have to kind of use a baby touch and then but every hour I'll check my focus. But the final thought I want to make about this is that I think one of the most fun things in using a camera, especially in photography, is pointing the camera. And in pointing the camera, you actually exercise a lot of judgment, because you have an infinite number of choices about where you want to point your camera. And I think that in what I enjoy about these kinds of shots, and all the shots I showed you today, is that you can exercise your judgment, and there's a lot of wonderful opportunity that just the simple act of pointing the camera entails. And I think that we can play with that to make that part of the picture.
So it's like a portrait and that's your canvas.
Yeah, that's right, because astrophotography is astronomy and photography. You got to think about both aspects of it. Thanks.
Well done.
Thank you, Sanjeev. Next up, Bob Olson.
How do I go back? Here we go. There's the horse head. All right. And the next thing I want you to look at is this area down here. This area down here is kind of red and, well, it's a bit other color, kind of a purpley color. So, yes. Sorry, I forgot you weren't up here. Horse head, there's the horse head right here, and that's what I'll talk about in just 1 second. But down here, take a look at the Orion Nebula M42. It's a kind of a purpley color, and that's because it's being excited gases in it. Okay, so here we go. Here's my horse head. Slightly longer focal length than Sanjeev used. And this image was taken as a kind of I'm setting up another telescope, and this was actually just an experimental shot. I needed to see what the scope was going to be doing and get some work on my camera. In the end, it turned out to be okay. But see whoopsie-daisy. Let's go back here. See the striations across here? Well, they're not actually there. There's a really bright star. If you just follow those striations back, you'll see where it is. It's a really bright star, and it's kind of flooding my camera. This is a reflecting telescope, and this is dust on the mirror and dust on my filters, and sort of swamping my image. And if I was really trying to make a really great image, I'd try and eliminate those, but I didn't care. All right. This is that M42 that we just looked at, and it's taken in hydrogen alpha. Can I ask you a question?
Sure.
How long was your exposure on the horse head?
Probably, well, that's a tough question, because what I did was it was probably about 3 hours, and of that I got about maybe 40 minutes of exposures, because I was fiddling with the knobs. And so, that's right. And so some of the images weren't very good. Every time you go, if you even walk near the telescope at that long focal length, the image is jiggled. Yeah. So this is then hydrogen alpha, which is red. They're really not red color. And this is the same image in oxygen 3, which is kind of greeny blue. So what I did was I took the hydrogen alpha image and I mapped it to red. And I took this image and made 2 copies of it and mapped it to green and blue. So that gave me my RGB for a color image right here. Now, this is not what it really looks like. This is not the real color, but it sort of shows some interesting detail inside of it. A very narrow band. And now, why would I do that rather than just take an RGB image? Well, the moon was out. And the narrow band images you can do them in moonlight, whereas RGB just gets washed out. Okay.
So, oh yes, It's not quite the end of the observations. Eric. Here comes Eric.
All right, so, well, I guess you guys know it was cloudy the night that this happened here. A couple of friends of mine, Ben Kluver, who's here, and Simon Como, and we decided we were going to head over to Rolf's place that night for a potluck. And we were kind of getting a bit late to get there, so I was able to check the midnight forecast from Environment Canada, and I saw that the cloud cover was pretty much from here till about, it seemed halfway to Toronto. So we got in the car and we just basically raced down the Highway 7. And just after we got past the County of Peterborough sign, we kind of figured, okay, this is we better get it, otherwise we're going to miss the actual totality. We could see it, through the thin layer of clouds, but I kind of was trying to get as far as we could so that we could get no clouds at all. But so, anyways, we started, as you can see, with it just a crescent phase. And the first two images on the left there are pretty much the same phase, except for I varied the exposure. The exposure time that I took for the fully illuminated moon was about it was 1/100th of a second, taken at ISO 100. And for comparison's sake, the totally eclipsed moon was taken 30 seconds long at ISO 1600. I took this with my my EQ 6 mount and a Skywatcher 80 millimeter ED refractor, and then I stuck on a 2x PowerMate. So I had it running at f15, which with my 5D Mark II allowed me to frame it nicely. There was just no way I was going to be able to do it with my 11-inch Smith Cassegrain. I could get the width of the moon, but I couldn't get the height just because of the size of the sensor. So yeah, any questions?
How did you manage to copyright it 7 months before it occurred?
Okay, so this is a bit of a compilation that Chris decided would be kind of neat to show. And this is essentially the right side of the picture, and he morphed it into the left side. So if you go back and forth between this, you can actually see the rotation and the time difference in the moon, which I had not actually caught. See, I mean, with Christmas just around the corner, my main intention of capturing this was to give this, as a big print to my sister for Christmas. So I was pretty much half asleep when I was processing this, and I had I had just over 1,000 frames that I had to go through. And originally I thought I'd do video processing using Registax, but there just was no way I was going to have enough time to do that. So I just went through every single frame individually and took the sharpest of frames. For the other reason, too, that the 5D Mark II, when it's doing video, is only taking every third line, essentially, because it's doing 1080p. It discards essentially 2/3 of the data that's hitting the sensor. So I figured I could get a sharper image of this. The other thing I should mention, too, is I've got a print of it here, too, if you guys want to see. It's printed 48 inches by 27 inches, and it actually looks a little more orange on the screen here than it does in the picture. In the picture, it looks a little more red. So if you want, I can show you on the table outside.
Well, thank you. Great work, Eric.
There we go. Very nice job. Now, I think we have an impromptu lunar challenge Eric is going to bring up here, and then we'll wrap it up for the evening.
Eric, that was a wonderful view. But the one that I want to see, and if you can find it for me, I want to see what the Earth looks like from the moon during a lunar eclipse. That would be pretty cool. The Lunar Reconnaissance Orbiter, I don't know if it's equipped to do that. It's orbiting the moon. If something like that could do it, I have never seen it. Anyone have a photo? Please bring it for the next meeting.
Interesting. I wonder if such a photo exists. Okay, so just a few of our routine items. First of all, for the Stanmont Library, Estelle's pick of the month. the book here, The Living Cosmos, Our Search for Life in the Universe. Get it now. Incidentally, Estelle mentioned to me this evening that there's quite a large number of books that have been out for a very long time, and she feels that it's perhaps time for some of those to come back to the library. So if you happen to be one of those people who's got some books that have been out a very long time, perhaps you could consider bringing them back into one of the upcoming meetings. Otherwise, we'll have to go through the list and actually figure out who you are.
What's the fine?
You have to come up and speak. No, we're pretty laid back about that. But it would be nice to get them back so some of the other members can take a look at the books. Next, please. Okay, so it seems like about time to encourage people. We're always looking for speakers, people to come up. It seems to me these days, just seat of the pants guess, about half of the proposed talks come to fruition. A lot of good ideas come along, but there seems to be a significant gap between having an idea and having a set of slides in hand and somebody behind the microphone. Well, we'd certainly like to encourage people. We do need new content, and it'd be nice to get some new speakers and not listen to me all the time up here. So if you have some ideas for a talk, by all means, bring them forward. We'll be happy to help you out with getting your materials together. You don't need to be a wizard with a computer. You don't need to know PowerPoint or anything else. Just tell us what you'd like to do and what your idea is, and we can give you a hand to put the whole presentation together. And if you do interpretive dance, well, that's okay. You're on your own. Okay. Anyway, if you do have an idea, talk to me or talk to Chris. You can get hold of me by email. You can see my email address up there, bill.meeting.chair@gmail.com. Lots of dots in there. Get hold of us. We'd welcome anything that you'd like to bring forward. Let me see now. Next one. Oops. There we go. Oh, okay. I think we both clicked at the same time, did we?
Yours won't work.
Oh, I see. He's tricky. He's changed computers on me. Okay. Post-meeting. The book library, I believe, is open. Estelle is here, so I would think that the door will be open. The equipment library. I have not seen Al tonight. Is Al here? Al is here. So you can speak to Al if you'd like to borrow something. Coffee and conversation, as usual, in the lobby. Art and Ann Fraser taking care of that as well. If you've got questions about membership or if you're looking for your card, then you can speak to Art Fraser out there. He's the lovely gentleman with the dark blue sweater with the Saturn on the back of it. Easy to figure out. Membership cards, not in astronauts anymore, so you'll notice the pile of astronauts is shrinking and shrinking and shrinking here as we go to electronic form. So just think that's only a small bush instead of a tree sitting out there now. We'll probably eventually see that disappear and they won't be up anymore. But anyway, you can see Art to pick up your membership card. Stephen McIntyre, is he here tonight, Stephen? No, I don't see him tonight. Nevertheless, there's cut-rate subscriptions to Sky and Telescope or Astronomy magazine available. You just need to go through Stephen. Basically, the publishers need to hear from the designated person from the club in order to give you the discount. But you can talk to him about getting your renewals done or to start a new subscription. Reminder, the rest of the museum is closed, so please stay to the lobby area. Don't wander off into the rest of the museum tonight. We'd like to keep on good terms with our hosts here. Snacks, drinks, and dinner. The usual reservation has been made at Kelsey's. Audience tonight, 108. Thanks to all the organizers and speakers. Without you, this meeting couldn't happen. Thanks to our host, the Canadian Science and Technology Museum. Any complaints, comments, anything else that you'd like to suggest with regard to the meetings, you can get hold of me. Again, there's my email address there. Feel free, or talk to me afterward as well. I have a question that I was asked to raise here. Brian McCullough, who was unable to make it tonight, asked if I would check on behalf of someone else if anyone knows anything about astronomy groups in the Renfrew area or out the west side there somewhere. Apparently there was a query about, clubs or other groups that a person could get hooked up with, and it's through Tristan at Focus Scientific. If anyone has information like that, maybe you could pass it on to help this person out. Let me see now. Next meeting, 8 p.m. Friday, February 4th. So first Friday of the month, and it'll be here, be there or be square. I would like to mention, I will be here for next meeting, but I've got a trip planned. I'm going to be out of town for the following meeting. And before I start trying to collar somebody, if there's someone here who would be kind enough to fill in for me as meeting chair for the one meeting, I'd really appreciate the help. If you think you might like to help out, maybe you could collar me afterward and just mention your name. Okay, thank you very much. I think that's the last slide, isn't it? Yes. So it's a little bit slippery on the roads. Please have a safe drive home, and good night.